Good evening. Welcome to the Mind of STEM, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this segment, I'm going to talk about a branch of engineering that deals with soil. And soil is very needed when it comes to engineering because you have to determine the type of soil, the stress of soil, the strain of soil. You want to make sure that your soil is suitable enough to construct foundations. So, the branch that this topic deals with is geotechnical engineering. Now, when we talk about anything dealing with geo, we're talking about rocks. So, the title of tonight's video is Why is Soil Mechanics Important in Civil Engineering? Why is soil mechanics important in civil engineering? Now, first of all, when we define soil mechanics, it is a discipline of civil engineering that predicts the soil performance characteristics by utilizing the engineering techniques of dynamics, fluid mechanics, and other technologies. Now, soil mechanics includes the study of soil composition, strength, consolidation, and the use of hydraulic principles to deal with issues concerning sediments and other deposits. Now, soil mechanics is one of the major sciences for resolving problems related to geology and geophysical engineering. Soil mechanics studies are very important for civil engineers because based on the findings of soil mechanics studies, engineering structures are constructed, or we can say built. Now, the type of construction, type of equipment to be used, type of foundation, support material, and many other aspects of construction works are largely affected by the soil mechanics studies. Now, basically, we study about soil formation modes, physical and chemical properties of soil, dynamic loading of soils, permeability, consolidation, etc. Now, in the subsequent sections of this commentary, I'm going to discuss detail about the aspects of soil mechanics duties. Now, first, we'll talk about the formation of soils. Now, soil is a combination of materials and organic elements that are in solid, gaseous, and aqueous forms. Now, soil consists of particle layers that are different from the original materials in their physical, mineralogical, and chemical properties because of the interactions between the atmosphere and hydrosphere and other reasons. Now, the particles of the soil are created from broken rocks that have been changed due to the chemical and environmental effects, including weather and erosion. Particles of soil are filled loosely. Also, when they're filled loosely, you can find that there is a creation of a soil formation that consists of pore spaces. Now, studying soil formation modes is important because it helps in determining properties of soil. Now, cohesiveness, adhesiveness, acidity of soil, and other related factors can easily be determined by allowing, or we can say by knowing about the type of soil that we have to deal with. Now, when I say allow, soil is tested based off of the ASTM specifications. You can use a nuclear density gauge, you can use a 10-pound rammer or a 5-pound rammer, blow counts. Usually test soils in labs when it comes to moisture and you use proctors. Now, we cannot draw any concrete conclusions. Again, we cannot draw any concrete conclusions merely by conducting soil studies, but we surely can narrow our research parameters by studying the basic characteristics of soil, like color, texture, and nature of soil. Now, again, when it comes to soil or soils or earth, or we call it fill if you're filling a foundation, we call it cut if you're taking soil or excavating. Well, soil has characteristics. Now, soil characteristics consist of solid, liquid, and gas. Now, when we deal with soil again, soil consists of different phases of solid, liquid, and gas and its characteristics that depend on the interacting behavior of these phases and on the stress applied. Again, let me repeat that so I can give you better information. When we deal with the basic characteristics of soils, soil consists of different phases of liquid, solid, and gas and its characteristics that depend on the interacting behavior of these phases and on the stress applied. Now, the solid phase includes clay, non-clay minerals, and organic matter. These elements are characterized by their size as clay, sand, and gravel. A liquid phase is composed of water that contains organic compounds available from chemical spills, waste, and groundwater, while the gas phase is normally air. The size, form, chemical properties, compressibility, and load carrying capability of the soil particles are determined by soil mineralogy, which is a science related with the chemistry, structure, and physical properties of minerals. The soil structure depends upon the arrangement of particles, particle groups, pore spaces, and the composition. Again, the structure of a soil depends upon the arrangement of particles, particle groups, pore spaces, and the composition. These basic characteristics determine the type of structure to be built and what external support measures, if any, has to be taken to make the structure last long and bear the effects of an earthquake, water seepage, and other external factors. Consolidation of soils is also an important factor that needs to be studied to make strong and durable structures. Consolidation is a procedure according to which the volume of soils is reduced by the application of a stress due to which the soil particles are packed together firmly, thereby decreasing the volume. Now, with the removal of the stress, the soil will bounce back and recover some of the volume lost during the process of consolidation. While studying consolidation, the crucial factors to be analyzed are the rate of consolidation and the amount of consolidation. Now, another important factor is the permeability of the soil. Why? Because all of the factors are closely associated with each other and they affect the overall design and construction process. For instance, if a structure is to be built on a soil with fine grains that have a low permeability, the flow of water through the soil voids will be less. Large water content in this soil may cause the structure to sink due to its weight. Now, the process of consolidation is fine grains is slow. Again, the process of consolidation in fine grained soils is slow. However, the extraction of pore water is simple in coarse grained soils since it moves freely within the region. Now, the consolidation rate will be influenced by the soil history, nature of soil, and load on the soil. Thus, all the factors like water content, permeability, consolidation, liquid limit are analyzed collectively. Now, soil mechanics studies are used to determine lateral earth pressure, bearing capacity of soil, and conduct slope stability analysis. Again, soil mechanics studies are used to determine lateral pressure, bearing capacity of soil, and the conduction slope stability studies, or we say conduct slope stability analysis. Now, these studies always help the civil engineer to design and construct better structures, and indirectly, these studies help in risk mitigation as well, because if we know beforehand how the soil mass is going to behave, we can take precautionary measures at the time of construction itself. So once again, when we deal with soil mechanics is a discipline of civil engineering that predicts the soil performance characteristics utilizing the engineering techniques of dynamics, fluid mechanics, and other technologies. Now that concludes this segment of why is soil mechanics important in civil engineering. If you like what I just presented, please comment, share, and subscribe. Now, if you're looking for content that deals with politics, economics, and social issues, check out my other channel, the 411 Talk Zone radio show. And also, I'm going to be bringing the Blog Talk Radio show back. Basically, the Blog Talk Radio show and the YouTube channel, the 411 Talk Zone radio show, present the same material. Now, with all of my channels, if you can't find me on STEM, which is on YouTube, the Mind of STEM channel on YouTube, or the 411 Talk Zone radio show on YouTube, and of course, my Blog Talk Radio show on Blog Talk Radio, you can find me on Twitter. Now, here's the deal. If you want to hear the 411 Talk Zone radio show in its entirely, and again, you can't find it on YouTube, you can find it on Twitter, MeWe, and Parler. Now, my Mind of STEM channel is going to be on Twitter and, of course, LinkedIn. I do that because MeWe and Parler are political types of platforms, where LinkedIn, that's more of a professional type of platform. And when it comes to my STEM videos, I believe that platform outside of Twitter is much better, so individuals can actually see the presentation of content like soil mechanics. But once again, I want to thank you all for viewing this information here on the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious night.